Let's compute an equilibrium prices example. This is exercise 1.61 in the text. Suppose an economy has exactly two sectors, goods and services. Each year, goods sells 80% to services and keeps the rest. Services sells 70% to goods and keeps the rest. So what would this look like? So here we have goods and services. Goods sends 80% to services and keeps the remaining 20% for itself. Services sends 70% of its output to goods and keeps 30% to itself. We want to find the equilibrium prices for the annual outputs that makes each sector income match its expenditures. So let G denote the price of annual output for goods and S denote the price of annual output for services. Here we're choosing units to be dollars, but you can repeat this for other units as well. And so remember, we have now G sends 80% of it to services, to S sends 70% back. So let's try to set up a linear system. Well, the expenditures for G, right, for goods, 20% of the value of G comes back, plus 70% of the value of the services, so 70% of S. Similarly, for services, we have 30% of the services value plus 80% of goods. And so this is the system we have. So we're going to put all the variables on one side to make it look more like the linear systems we've been dealing with, and we'll notice it's a linear system with two equations and two unknowns. The unknowns are G and S. We set up the augmented matrix, we row reduce and solve. I like to put boxes around my pivots so then it's clear the non-pivot column, which is the S column, tells us that S is free, and the pivot column, which is the G column, tells us that G is basic. So we can solve. S is some parameter t, and G is 7/8 t. Now notice this is a word problem, and so G and S represent prices, so we need t to be bigger than or equal to 0. Any choice of t will give us such a solution to this word problem. The only thing that matters is the ratio. And so, for example, if we choose t equals 8, just to make the numbers nice, one possible solution is services value is $8 and the goods value is 7.